All right, one last little bit of derivative work. So we have something called the product rule. So the product rule we need to use when we have two functions multiplied times each other. So remember, d over dx means take the derivative of. So if I have a constant times a function, remember, I just carry the constant along and take the derivative. So if it's not a constant, if they're both functions, I have this product rule. So here it is. So what it says is you write the first function down, and then you take the derivative of the second. First, derivative of the second, plus for product rule. Second, write the second one down, and then you multiply by the derivative of the first. So I kind of shortened it to say first d second plus second d first. Because it's added, you could do it in the other direction as well. But the hardest thing about product rule is remembering to do it, not to just carry things along. All right, so let's do it. This says take the derivative of this product. So if you need to, it can be helpful to rewrite that root x so that, and to kind of emphasize I have a product here. So we do it. So first d second plus second d first. And that's it. No simplifying needed. All right, so here I am going to spend time simplifying before I go take the derivative. I'm not going to multiply it out, but I am going to rewrite this a over b times t. Whoops, b, there we go. A over b times t. So just separating the constants away from the letter t, and then c, and then minus d, and then this t, I'm just going to write it this in the denominator, t to the negative 1. All right, now I'm ready to do my product rule. So y prime will be first d second. So taking the derivative of this, the derivative of c is 0. The derivative of this, I'll bring the negative down, so I'll go to a positive t, t to the negative 2, plus second d first. Take the derivative of the first, 3t squared, carry along this a over b as a constant, and the derivative of t is 1. And that's all you need. All right, so we also have something called the quotient rule. So the quotient rule you use when there's division. All right, so I'm going to need to just listen for a second. So if I've got this derivative, right, of this low function and this high function, right? So low is the g and high is the f of x. So just listen. So it's low d high minus high d low, square the bottom, and off you go. It rhymes, yes? Okay, so you always start at the bottom of the ladder. So low d high minus high d low, square the bottom, and off you go. D low and square the bottom and off you go have to rhyme. And quotient rule has subtraction where product rule had the plus. Okay, so I'm going to encourage you never to multiply the denominator out because it's never going to be useful. So here we go. So the hardest thing is just recognizing it is a quotient rule. So we just go do it. So we start with the low, start at the bottom of the ladder. So low d high, let's just go do it. So the derivative of 2 is 0, the derivative of t is 1, minus high d low, taking the derivative of this gives me 2t plus 1, all over square the bottom, and off you go. Then perhaps you could multiply that out. Sometimes you'll see my answers I do. Again, we're going to be moving into applying this and doing something with it. For now, I'm just going to leave my answers like that. All right, let's do it. So low d high, need parentheses, right? So remember how to take the derivative of e to the x is just e to the x, carry the 2 along. The derivative of negative x is negative 1, minus high d low, 2x, the derivative of negative 4 is 0, over square the bottom, and off you go. So it's easy to forget to write the denominator in, so don't forget. Okay, as fun as quotient rule rhyme is, it's a lot of work, right? So I could go do quotient rule over here. So I could say low d high, so 3x squared minus 6, minus high d low, so that would give me 6x, square the bottom, and off you go. Okay, so that would be fine. That'd be a lot of work to multiply out. I could, because I see subtraction in the numerator, I'm going to fix this before I go in and take the derivative. So if I fix this, I have not done the derivative, right? I'm still just talking about y. So this is the same as saying the number 1/3 times x. And here, this would give me the number 2 over x. So if I wanted to just take one more step, now to find the derivative, so it would be 1/3, and then plus 2x to the negative 2. Wow, that is so much nicer than this, right? So if you have a nice denominator that's not it's a monomial or just one term, you can separate it and make your life much easier. All right, let's finish these off here. So I want to find the equation of the tangent line to this at this point. Okay, so I know to find the slope of the tangent line, that's f prime at 1, right? That's the slope of the tangent line at x equal 1 to f of x, right? That's what I need. Okay, so first I want to find the derivative. So the f of x is the same as y. So the hardest thing is recognizing product rule is here. So I'm going to encourage you to think of 3x as the first function, e to the x is the second function. So first, d second, derivative of e to the x is e to the x, plus second, e to the x, times the derivative of 3x, which is 3. Okay, so now I want to find f prime at 1. So I'm going to plug in x equal 1. So I get 3e plus, and this will give me 3e. So these two e's I can add together to get 6e. So this is the slope of the tangent line. That's like the m. Okay, so what do I need to put together? An equation of the tangent line. I need a point and a slope. I have the x. How do I find the y value? I find the y value by putting x into the function. So if I put x equal 1 into the function, I get 3e. Oh, look at that. All 3 e's all over the place. Okay, so my point is 1, 3e, and my slope is this. So I put these two things together. So y minus 3e equal 6e x minus 1. That's a fine answer. Don't do anything to that. All right, how many more do I have left to go? Let's take a break here.